All right, so we are talking about now trigonometry terminology under 6.3. So this is still 6.3 continued. And this is trigonometry terminology. Okay? So, trigonometry terminology. All right? Now, there are, sorry, that's an A. There are two vocabulary terms that may appear in the application of trigonometry. Okay? Those being the angle of elevation, and is always measured from the ground up. Okay? It is an upward angle from the horizontal line. It is always inside the triangle. Okay? That's the angle of elevation. All right? You can think of the angle of elevation in relation to the movement of your eyes. Okay? If you are looking straight ahead, okay, you must raise, elevate, your eyes to see the top of an object. In the case of this figure I'm going to use, I'm going to take in reference to a tree. Okay, so if I have a tree, pretty little tree that you ever did see. Okay. And I have the height at which I'm looking at the object, or the height of the object, and there's me standing off to the side. Okay? Okay? I'm looking up at the tree at a certain angle of elevation, which is right here. I'm going to label that as theta. Okay? This could be triangle BCA. Okay? So you have to look up that angle of elevation. So anytime you look off the horizon, the angle will basically be next to that horizon line. And that's important for the next one we're going to talk about shortly after this. Okay? In this diagram, okay, x degrees marks the angle of elevation of the top of the tree as seen from a point on the ground. Okay. Sorry, I'm going to the camera. Now, if you're looking, however, let's say you're in the tree and you're looking down. Let's say you're a squirrel up there staring at that guy and wondering, what the heck is he doing? Okay? If you're looking down at that person, the thing is, remember, I told you that the angle of elevation in this case is always going to be next to the horizon line. When you look down, you're looking off of whatever horizon line you're looking at. In this case, it's up in the sky. And looking down off of it, then you're going to basically have an angle of depression. Pause there for a second. Okay. The angle of depression is always outside the triangle. Okay? It is never inside the triangle. Okay? And it is a downward angle from a horizontal line. Okay? All right? Okay. You can think of the angle of depression in relation to the movement of your eyes. Okay? You are standing, let's say, at the top of a lighthouse. Okay? If you are looking straight ahead, okay, you must lower, okay, or depress your eyes to see the water or boat, water or boats. Okay? do the figure on the next page. I apologize. So try to get it all on one page. I just can get it to fit. All right. All right. I'm going to actually do the figure on a sticky note really quickly. Okay. So if we have our lighthouse, okay, there's a lighthouse. And we're standing up here. That little dot represents us. And we're looking down to the harbor or to the bay or whatever you want to call it. Okay? We see a boat down there. Okay, let's say we see a boat. Okay? We'll call this C. We'll call this A. And then the height from here all the way down to where this line meets this line. There we go. Okay? And then we'll call this B, which of course is a right angle. However, we don't know what the angles are. All we know is that the angle which we're looking down. Remember, I told you that the angle of depression, in this case, is always going to be, okay, wherever you're looking down, it'll be above your eyes. Elevation, if you look up, it'll be below your eyes. Okay? Wherever you changed off of, i.e., it's always off the horizon or the parallel skylines, basically, wherever you're looking out straight. Okay? And that's X degrees in there. All right? In this figure, X degrees marks the angle of depression of the boat at C from the top of the lighthouse. Oops. There we go. Now, before we conclude, there's a few notes I want to make sure you're made aware of. Okay? That involve the angle of depression and angle of elevation for that matter. Okay? So we'll actually label this as C. Okay? All right, it's notes / important points. Okay? You should notice how the horizontal line in the angle of depression is parallel to the ground. Okay? The fact that horizontal lines are always parallel guarantees that the alternate interior angles are equal, not congruent, but equal in measure. Okay? Simply put, This means that the, do this in a different color, angle of elevation, ELEV dot for short, is equal to the angle of depression. Okay? That's basically what that means. And that will hold true for every single one of these types of problems. Your angle of elevation is identical to angle of depression. So they give you the elevation, even though they tell you you're looking down an object that it might be elevated to look up at you at a certain object, you still should be able to figure out everything you need. Okay? Now, one more thing we need to talk about. It should be a D, sorry. Skip a line. There we go. So D, when solving a problem with an angle of depression, you need to find the measure of an angle inside the triangle. Okay. There are two options in doing this. Okay. Option 1. Okay. Find the adjacent angle to the angle of depression. Okay. So, in other words, if you have triangle like so, that is depressed, or an angle of depression looking down from B at 38 degrees. This is B, this is C, this is A, this is your opposite side. Oops, I should have done that in a different color, sorry. This is your opposite side, your adjacent side, and your hypotenuse. I'll do the adjacent like usual, OPP, ADJ, and HYP. Okay. That means that we need to figure out what this missing angle is here. This missing angle is 90 minus 38, which gives me 52 degrees. They are complements because it's a right angle that's formed right here. Okay? And because of that, we can then say that the tangent of 52 degrees equals the opposite side, in this case, we'll just label him x over 40, which can be solved for so that you have 40 tangent of 52 equal to x, and that is roughly x is equal to 51 feet. So that's the first option. The second option is a tad bit different. Option 2. Option 2 is you utilize the fact that the angles, or sorry, the angle, not angles, get rid of that S, the angle of depression is equal to the angle of elevation. Okay? And you can basically label the alternate interior angle the same measurement. Right? This is 38 degrees. Because, remember, these guys are in parallel. So that means that this angle is also 38 degrees. We have our adjacent side, our opposite side, and our hypotenuse. With that all said, we can then just do the tangent. And this is x, obviously. And let's just say that the opposite side, sorry, I forgot to mention up here on the previous one, the opposite side there is 40 feet. My bad. Okay. Yes, you can do tangent of 38 equals 40 over x. But in this case, you'll have to multiply both sides by x and then divide by tangent of 38. So you're going to have x tan of 38 equals 40. Divide by the tangent of 38 from both sides. And you should get roughly x equals 51 feet. You should get the same answer. If you don't, something's wrong. Okay? And that's how you calculate angle of depression. Hopefully found that helpful.